Hello. This is the third session on the topic of confounding, where I'll walk you through some of the examples of how we address confounding in terms of the analysis and in terms of the steps that I talked to you in the previous session. Let's look at this example. Here, consider that we're doing a case control study, which is designed to estimate the possible effect of oral contraceptive use on the incidence of breast cancer. As per literature, socioeconomic status is a known risk factor for breast cancer, and it's probably also related to oral contraceptive use. So we take socioeconomic status as a potential confounder for the effect of oral contraceptive use on breast cancer. Here, this table shows you the crude odds ratio between the effect of oral contraceptive use on breast cancer. The crude odds ratio is 1.89. The next step was to do a stratified analysis. So the stratification was done on the basis of socioeconomic status. So there are three strata: low socioeconomic status, middle socioeconomic status, and high socioeconomic status. This entire data of 195 oral contraceptive users who had breast cancer, and those 140 who did not have breast cancer among the users, and similarly 155 non-OC users who had breast cancer and 210 non-OC users who did not have breast cancer, were all stratified based on their socioeconomic status. And then we calculated the stratum-specific odds ratio. So for the stratum of low socioeconomic status, middle socioeconomic status, and high socioeconomic status, separately an odds ratio was calculated. And here, as you can see, the odds ratio for each one of these strata is 1. So you can see that the stratum-specific odds ratios are similar to each other. They're all 1. And further, the stratum-specific odds ratio are different from the crude odds ratio. So one is different, all of them are different from the crude odds ratio of 1.89. The next step would be to then, how do we to calculate what is known as the adjusted odds ratio. The adjusted odds ratio, the Mantel-Hansel odds ratio, was calculated, and that also came out to be 1. So comparing the adjusted and the crude, we can see that yes, there is a difference between the adjusted, which is 1, and the crude odds ratio, which is 1.89. So the crude or the unadjusted odds ratio is larger than the stratum-specific odds ratio as well as the adjusted odds ratio. So hence, socioeconomic status actually appears to positively confound the effect of oral contraceptive use on breast cancer. What that means is that if we did not consider the confounding effect of socioeconomic status, we would have overestimated the effect of oral contraceptive use on breast cancer. That is 1.89. Whereas in reality, after adjusting for socioeconomic status, oral contraceptive use does not appear to be a risk factor for breast cancer in this particular study population. Let's look at the next example. This is an example of a cohort study which was done to estimate the effect of exposure to wood dust on the occurrence of chronic respiratory disease in middle-aged male furniture workers. Here, cigarette smoking, which is a known cause of chronic respiratory disease, was considered as a confounder, and we try to see whether it actually is a confounder or not, and does it confound the effect of wood dust on exposure to wood dust on chronic respiratory disease. So again, resorting to stratified analysis. So the crude risk ratio here is 1.29. This data was then stratified into two strata, one of smokers, the other of non-smokers. Among the smokers, the risk ratio was 1.66. Among the non-smokers, the risk ratio was 1.65. So as you can see here, again, the risk ratio is similar in the two strata, but it looks different from the crude, which is 1.29. So the authors, he calculated the adjusted risk ratio, which was also 1.66. And then we can see that the crude or the unadjusted risk ratio is lower than the adjusted risk ratio, which is 1.66. Hence, we can say that smoking appears to negatively confound the effect of wood dust exposure on chronic respiratory disease. What that means is that the true effect of exposure to wood dust on chronic respiratory disease is actually much higher after having adjusted for smoking. And if we had not adjusted for smoking, then we would have underestimated the effect of wood dust exposure on chronic respiratory disease. So the final measure of association that we would want to report would be the adjusted and not the crude. A third example here again is of a cohort study which was done to estimate the effect of physical activity level on the occurrence of CHD in a population of adults aged 50 to 69 years. What is known from literature is that age and sex are known risk factors for CHD. And so we would want to control for these two variables and see whether, of course, to identify whether they are actually confounders or not. And if they are, we would want to adjust for them. So for this purpose, again, as you can see here, first we calculated the crude risk ratio for the effect of physical activity on CHD. The crude risk ratio is 0.54. The authors then made 4 strata. Since here now we are looking at 2 potential confounders at the same time, sex, male, female, and age group. Since this was the study population itself was limited to 50 to 69 years, so the authors made 2 strata based on age, 50 to 59 and 60 to 69, sort of older and younger, but within that age. So eventually you have males 50 to 59 years, males 60 to 69 years, female 50 to 59 year old, and female 60 to 69 year old. And so for each of these 4 strata, the risk ratio is calculated, the stratum specific risk ratio. And here you can see that each of these strata, the stratum specific risk ratio is also 0.54. So in terms of the steps that we talked earlier, the stratum specific risk ratios are similar to each other. And interestingly, the stratum specific risk ratios are also similar to the crude risk ratio, which points to the fact that the sex and age are not making any difference to the risk ratio. We might want to calculate the adjusted risk ratio here as well, and if we had done that, that would also have come out, because it's a weighted average of the stratum specific risk ratios, it would also be 0.54. So what that means is, so here the crude and the adjusted are similar to each other, and hence we can infer that age and sex do not appear to confound the effect of physical activity level on CHD, and hence the crude risk ratio is unconfounded or unbiased by age and sex. Of course, there could be other confounders, but these are the only two that we have checked at this point of time. And so we can say that what we would finally report is the crude risk ratio here, and there would not be a need to calculate or report an adjusted risk ratio adjusted for just sex and age. And we can then conclude that yes, the risk of CHD in active adults, so people who are exposed to a certain level of physical activity, is nearly half, that is 0.5, compared to the risk in the sedentary adults, assuming that there is no other confounding by any other factors other than sex and age. Because if there were other confounders, we would also have to identify them, check them out, and then see if they are, then we would also have to adjust for them as well. The last example here is of a cross-sectional study, or of an analytical cross-sectional study, where the authors wanted to estimate the effect of social support level on the presence of hypertension in a rural adult population in the United States. In United States, race, which is essentially black or white, is a known risk factor for hypertension. So the authors wanted to check whether is race a confounder, and should it be adjusted to get the true effect of social support on hypertension. So here, for the analytical cross-section study, they estimated the odds ratio. the crude odds ratio was 1.47. They stratified based on race, which is black and white. And here you can see that the stratified odds ratio for the whites is 1.12 and the stratified odds ratio for the blacks is 1.85. So what do we see here? And then the stratum specific odds ratio between white and black are different from each other, and they're also different from the crude. When they calculated the adjusted odds ratio, they found that the adjusted odds ratio adjusted for race was 1.44. So here what we see that the adjusted odds ratio is almost similar to the crude odds ratio, and so probably race does not appear to be a confounder for the effect of social support on hypertension. And so we need not report the adjusted odds ratio, and finally what we would report is the crude odds ratio. Of course, there is another phenomenon that is happening here. As you can see, the stratum specific odds ratios, the two strata, the effects are different among whites and blacks. And this phenomenon, where we see that the stratum specific measures of association are different from each other, is what is known as effect measure modification. And that is what we will be talking about in another session. But here, what we have identified is that at least in terms of confounding, the crude odds ratio is not confounded, is not biased because of race. And hence, we can report the crude odds ratio of 1.47 or 1.5. Thank you.